Alright, so we're going to solve some quadratic equations and then look at some quadratic functions. Remember, quadratic equations are ones that have that x squared, and usually if we're going to solve them, we get everything on one side so it's equal to 0. So usually they can be written in the form ax squared plus bx plus c equals 0. And the reason we get it set equal to 0 because we have two main ways of solving them. One is factoring, because if things are set equal to 0, you can set independent ones equal to 0. And the quadratic formula allows you to isolate an x, which you can't really do from just solving techniques otherwise. So let's see here. Let's try and do a couple of examples. Here we go. So the first one we're going to try and solve, A, is 2x squared minus 5 equals 3x. And as I said, the first thing you want to do is make sure you get everything on one side. So 2x squared minus 3x minus 5 equals 0. So we can try factoring this thing. If it factors, it'll be two things that multiply together to give me negative 10 and add up to be negative 3. And in this case, I believe that could be negative 5 and positive 2. So there's many different ways to factor. So if you've got a way that works for you, go ahead and use it. But this will factor into, let's see, 2x minus 5, 2x plus 2, and in my technique, we will pull a 2 out of the second one and throw it away. So it really factors into 2x minus 5 times x plus 1. If you use a different method, you should end up here. If you want to talk about my method a little bit more, let me know. But once we have both of these things multiplied together and factored, we can set them independently equal to 0. So 2x minus 5 equals 0. X plus 1 equals 0. So isolating x here, we'll get x is 5 halves and x is negative 1. Okay. So two solutions for that quadratic. The next one we're going to do here, B, 2x squared minus 7x minus 3 equals 0. Trying to look at this thing. I don't think it factors off the top of my head. So I'm going to try the quadratic formula. Everything is already on one side. The a is 2, the b is negative 7, and the c is negative 3. There's nothing wrong with trying to factor it. If it does factor, great. If not, we'll go to quadratic formula anyway. But let's see here. So setting that up, we'll have x equals negative b, so that'll be a positive 7, plus or minus square root of b squared, which is 49, minus 4ac. So that'd be minus times a minus. So 4ac, I believe that's 24. Let's see if that's right. 4 times 2 times 3. Yep. All over 2a, so all over 4. So clean this up a little bit. It's 7 plus or minus the square root of, I believe that is 5373. All over 4. And that does not have a nice root. 73, I believe, is prime. So there's not much we could do with that except turn it into a decimal. But do keep in mind that this is two answers. 7 plus the square root of 73 divided by 4, and 7 minus the square root of 73 divided by 4. So you'll get two completely different answers if you put that in the calculator. Alright, the last one here, C, 5x squared plus 9x plus 4 equals 0. Everything's already on one side. You can use, I believe this one does factor, but let's use quadratic formula anyway. A is 5, B is 9, and C is 4. So it doesn't matter which way you solve this. Let's see. X will be negative b, so negative 9, plus or minus square root of b squared, which will be 81, minus 4ac, so I believe that's minus 80. Is that right? Yep. All over 2a, so all over 10. So we get x equals negative 9 plus or minus the square root of 1, which is 1, all over 10. So that gives me two answers. Negative 9 minus 1 over 10, and negative 9 plus 1 over 10. So that is negative 10 over 10, so that is a negative 1. And negative 8 over 10, which will give me negative 4/5. So I still get two answers. And the fact that these turn out to be nice whole numbers or fractions shows me that I could have factored that. Okay. All right, let's go down to functions. So quadratic functions look just like quadratic equations, but they're functions. You plug something in, you never know what you'll get out. So f of x equals ax squared plus bx plus c. And we're just going to quickly graph the most basic one, which is f of x equals x squared. So whatever we plug in, we square. So my little table here has the integers negative 3 to positive 3 squared. So negative 3 squared is a positive 9. Negative 2 squared is a positive 4. Negative 1 squared is 1. 0 squared is 1. Excuse me, 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. So this gives me sets of x, y points that I can plot. So negative 3, 9. Negative 2, 4. 1, 1. 0, 0. And so forth. But you should have an understanding that this makes a U-shaped parabola, is what we call it. It looks kind of like a U. Now for different quadratics, they all have that U shape, but it could be an upside down U, or that U could be moved around on your page. Okay, so just kind of keep that in mind. Hold on one second while my computer catches up here. Okay, we got caught up there. So the next concept we want to go to here is with that U-shaped parabola, talk about the vertex. And the vertex is the middle or the turning point of the U-shaped parabola. So think of it as a horseshoe, that U-shaped graph that we have. And think of the vertex as the place you would hold that horseshoe in the middle if you're going to throw it appropriately. So being the fact that it's U-shaped, and in some cases it can be a U-shaped up or a U-shaped down, that vertex part gives me the lowest point, which would be a minimum on a graph, or the highest point, which would be a maximum on a graph. Okay, very unique quality to quadratics. So if we do have our function in the form of ax squared plus bx plus c, basically the middle of the x-intercepts, or the middle of the quadratic formula, gives us the location of that vertex. So the x value of the vertex can always be found using negative b over 2a. Negative b over 2a. And of course, if you have an x, you can plug that x value in to find a y. So let's do a couple problems with that. So we're going to come down here, and we've got two functions. Let's do one. So we're going to find the intercepts, vertex, and then we're going to graph the function. So the first one is f of x equals x squared plus 4x plus 3. So let's just kind of run back to our intercepts. Remember, x-intercepts, let y be 0. Got a little messy there. Let y be 0. So if we do that, we set our quadratic equal to 0. So now you see why we wanted to make sure we could solve quadratic equations. This one factors. 0 will be equal to x plus 1 times x plus 3. And if you set them equal to 0 independently, you'll solve and you'll get x is negative 1. So we'll have an intercept at negative 1, 0. And we will get x equals negative 3. So we will have an intercept at negative 3, 0. The y-intercept, remember that's where we let x equal 0. Okay, so in that case, if we let x equal 0, we'll get y equal 0 squared plus 4 times 0 plus 3. So we get the point 0, 3. Okay, and let's slide down a little bit. Always more than we want, it seems like. There we go. So now we want the vertex. And remember, the x part of that comes from negative b over 2a. So negative b over 2a here would be negative 4 over 2 or negative 2. So that's the x part of it. So then we want to plug that negative 2 into our function. So negative 2 squared plus 4 times negative 2 plus 3. So in that case, we will get 4 minus 8 plus 3, and that will give me negative 1. So my vertex will be negative 2, negative 1, it looks like. So negative 2, negative 1. So let's try and graph the things that we found. We found that we had x-intercepts at negative 3 and negative 1. We had a y-intercept at, I believe it was negative 3, or was it positive 3? Positive 3. I'm sorry, it keeps jumping up and down here. Positive 3. And we have a vertex at negative 2, negative 1. So that vertex is the middle of our graph, and it's the highest or lowest. So we're going to make that U shape out of the vertex. So we're going to come over to the right since we got more points there and connect. And we're going to do the same thing on the left. Okay? All right. Now let's do the other one if we got time here. We're going to make it very quick. Y equals negative 4x squared minus 8x minus 3. If I'm going to factor this thing, when I set it equal to 0 for the x-intercept, I'm going to pull out a negative. So it'll be 4x squared plus 8x plus 3. And let me see, does that factor? Two things that multiply to give me 12 and add up to be 8. 2 and 6. Okay. So we'll have 4x plus 2. 4x plus 6. We can throw a few things away there. But in the end, we'll get x-intercepts at negative 1/2, 0, and negative 3/2, 0. And my y-intercept is when we let x equal 0. And if we go back up to our function, we'll get 0 minus 3, so we get 0, negative 3. So we got some points there. And now we want the vertex. X equals negative b over 2a. And in this case, that'll be 8 over negative 8. So negative 1, I believe. Yes. So negative 1, and then we have to calculate that. So if we plug negative 1 in, it looks like we will get negative 4 plus 8 minus 3. So I don't know why, but it looks like we got 1 here. So we got the point negative 1, 1. So let's see if we can graph all that. Negative 1/2 and negative 3/2 for our x-intercepts. Negative 3 for our y-intercept, and the point negative 1, positive 1 for our vertex. So we're going to come out this side and connecting, and we're going to connect out the other side with the U. So try to go back up here and show you all the points that I found. I don't have it where I can show you the graph at the same time, but here are the x-intercepts that I plotted, negative 1/2, negative 3/2. The y-intercept, negative 3, and the vertex, negative 1, 1. And all that worked out very nicely on my graph, as long as you have good graph paper and try and hold it as best you can. All right, thank you.